Alright, hello everyone, this is Mr. Crozier. I wanted to give you some help with some vector notes for lesson 3.3. Alright, one of the first things you're going to have to do is find vectors from graphs. And we've already defined vectors as a change in position from one location to another, and it's along this line, and we have an arrow here showing the direction. So what is this vector? Well, it starts here and it goes this way, and we write it as, vector A here. We go ahead and write it as the two components, and the first component is the vertical or the horizontal change, and it goes from -2 to 4. So if I subtract back, 4 minus -2 is 6. And the second component is a vertical change, and going up and down, it goes from -1 up to 2. 2 minus -1 is 3. And you can go ahead and look at that, and you can see that in here, this from the initial point to the terminal point, it goes 1, 2, 3, 4, 5, 6. 1, 2, 3. Alright, those are the components. Another way that we haven't talked about how to write them yet is we can refer to it in this notation right here. Everything's the exact same, but we call an I a step in the horizontal direction, and a J is a step in the vertical direction. So we're going 6 horizontal steps, 1, 2, 3, 4, 5, 6, and 3 vertical steps, 1, 2, 3. It's just the exact same vector, just a different notation you want to get accustomed to. Alright, and the last thing we want to do is find the magnitude here. Well, the magnitude is the length of it, and we could think of it as a right triangle, and a squared plus b squared equals c squared, and these are our two legs. So we square them, add them together. 36 plus 9 is 45, and we'll want to simplify that. It's 9 times 5, or 3 root 5 for a magnitude. Alright, on the next one, well, what are we going here? We're going from up here down to here. Well, let's figure out the horizontal change. -3 minus 3, it's -6. So this, let's call this vector B. Vector B is a -6, 6 to the left, and then it goes down from 0, or from 4 down to 0. 0 minus 4 is a -4. Alright, let's do it with our new notation. That'd be a -6i minus 4j. Exact same thing, just get used to this notation. And the magnitude, two lines is the magnitude. A squared plus b squared, that's the square root of 52. And 52 is 4 times 13, so it's 2 root 13. Alright, on the last one, well, what is the vector? Let's call this vector C. The horizontal change, -2 minus -2 is 0. There is no horizontal change. Vertical change, 4 minus -3 is 7. How do we write that in our new notation? Well, no I steps and 7j. And the magnitude, a squared plus b squared would be 49, square rooted just 7. Alright, after you've identified vectors from graphs, you'll just want to be able to identify them from points. So if we have an initial point here to a terminal point here, what is that vector? Let's call it vector V. Well, has two components, and we're just going to subtract back. But I always want to help you figure out these by going back to the graph here. If I graph this 5, 3, 1, 2, 3, 4, 5, 1, 2, 3, it's here, and the next point is 5, 7, or 7, 8, 7, -8, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Take a look at what our vector is doing. It's starting here and it's going down here. So 7 minus 5 is 2. And you can see those two steps, right? We're moving 2 spaces to the right. And -8 minus 3 is -11. We're going down 11 steps. -2 to the right, or sorry, 2 steps to the right and 11 steps down. 2, another name for it, 2 I steps minus 11 j steps, if you want to think of it that way. Just get comfortable with both notations. And so what is the magnitude here? A squared plus b squared would be 4 plus 121, 125. Well, that's 25 times 5, so it would be 5 root 5. The name, the magnitude. Alright, last thing you want to be able to do is do some vector operations. We did a graph of these where we graphed this vector and this vector and this vector, and if we add the two vectors together, it's this graph plus this graph. All we have to do, it's a simple problem, all we have to do is add the two vectors. Add the a values to the b values. So I like to think of it as just, it's the 3, negative 5 being added to the 8, negative 1. It's 11, negative 6. Just the two vectors put together. And you can write it in the other notation. You could find the magnitude if it was required. Alright, we have 2a's minus a b. Well, 2a's, so I have 3 and a negative 5 and a 3 and a negative 5. Subtracting a b. So if I subtract this, that's a negative 8. And if I subtract a negative, that's 1. If I were to add all these vectors together, I would have a negative 2. And I would have a negative 9. Again, you could get that by graphing. You could get that simply by doing it in your head. 2 times 3 is 6, minus an 8, it's a negative 2, or you could write it out. And the last one, we have a c vector. So here's that different notation. Well, we could simply write it as the exact same thing if it's a little bit easier for you that way. 2 steps in the I direction, 1 step in the j direction, and they're all positive. So I have a c, which is this, plus 3 of that. Well, how about this? How about we put it as a c is first, 2 plus 3 of the b values. We're going to have to jump down to the b values, 3 of those b values. And that would make 26. And now let's use the second coordinate in here. We have a 1 here for the c, plus 3 of the b values, 3 of those negative 1s. Oops, let's write it the same way. 3 of the negative 1s, so that's a negative 2. So there's my vector. Again, I'll show it to you a different way. I'm going to take the c vector, which is 2 and 1, and I'm going to add 3 b vectors, 8, negative 1, 8, negative 1, 8, negative 1. And if you do that, you'll get to the same spot right there. However you want to do it, you're just putting those vectors together. Alright, I hope this helps. This is some information on vectors, some of the basic skills you'll need to work with vectors this semester.